Welcome back to another video lesson on solving quadratic equations with the quadratic formula. In this video, I'm going to give you 3 examples of how to solve and get 2 real irrational solutions. And this is an extra level of difficulty. So make sure you've accessed the video on how to simplify radicals if you need to, because that's an extra step we'll be doing in this set of problems. So let's get started. First of all, quadratic equations must be in standard form before you plug them into the quadratic formula. I hope you've gotten used to that by now. So let's get going here. Number 1 is not set up well. I have to move things around to get it into standard form. So I'm subtracting 6k from 9k, and I'm adding 2 to 2. The whole goal here is to get a 0 on the right. So if I rewrite this, I've got negative 3k squared, 9 minus 6 is positive 3k, and 2 plus 2 is 4. Okay, so now it's really easy for me to identify what the a, b, and c are in the formula. A is negative 3, b is positive 3, and c is positive 4. Put everything in the right position in the formula. This calls for negative b. My b value is positive, so I'm going to plug it in as negative 3 plus or minus square root of b squared, which will be 3 squared, minus 4 times the a value, which is negative 3, times the c value of 4, all over 2 times the a value of negative 3. Make sure you've written that down correctly before we keep going. Next, I'm going to go over to Desmos so I can calculate the discriminant all in one step. 3 squared minus 4 times negative 3 times 4. And I get a discriminant value of 57. So that means the number underneath the radical is 57. Okay, now this is a pretty big deal. I cannot find a perfect value of 57. If I go over to Desmos and try to find the square root of 57, I'm going to get really frustrated because I get an irrational decimal value. And we are not mixing decimals into our quadratic formula. So I have to take a second approach. I have to simplify 57. So I'm just going to pull out a scrap sheet of paper to help me over here, or you could go down in the margin below, and we need to simplify 57. Well, what can 57 be divided by? You can try a few things. You can play with Desmos. I know that 60 can be divided by 3, and 57 is just a little bit less than that. So if I do 57 divided by 3, I'm going to get 19. So 57 can break into 3 and 19. Now both of those are prime, and I have no partners, no pairs to pull out. So 57 is simplified. I cannot go any further from that. So if I break this into 2 steps, it's actually going to be more to write than if I just leave it as is. I'd have negative 3 plus the square root of 57 over negative 6. And then I'd have negative 3 minus the square root of 57 over negative 6. And I don't want to write that twice. So I'm going to leave it with the plus minus sign in it. And that is my final irrational answer. I know there are 2 solutions here. One would be a plus something, and one would be a minus something. Now, if you want to go over to Desmos and get a decimal approximation, you can. And start with a square root, negative 3 plus the square root of 57 all over negative 6. And do it again, negative 3 minus the square root of 57 all over negative 6. Okay, so I get 2 very different irrational decimals. Well, guys, don't forget you could always try these you could always check your work by graphing. So I'm going to type in the function y equals negative 3x squared plus 3x plus 4. And I'm going to look at my two solution points here. And you're going to notice that they round to the same thing I got from the irrational solutions on the left. So you can still check your work here, but we are not going to answer in decimal form. Let's see a second example. Okay. Example number 2 is not in standard form. I think we're getting better at this, I hope. Move everything over. The goal is to have the right side equal to 0. So I'm going to add an m. So negative 7 plus 1 is negative 6. And I'm going to add an 8. Negative 5 plus 8 is positive 3. So my a value is 1. My b value is negative 6. And the c value is 3. I'm going to put everything into the quadratic equation. I have my formula up here to help out. This calls for a negative b, so a negative of negative 6 is positive 6, plus or minus, big square root. This is b value squared, so negative 6 squared, minus 4 times the a value of 1 times the c value of 3, all over 2 times the a value of 1. All right, I hope you're like, what do I do next? I know what to do next. Figure out what the discriminant is. Go over to Desmos and let Desmos do all this hard work for you. Negative 6 squared minus 4 times 1 times 3. And we are getting a discriminant of 24. The number beneath the radical is 24. 2 times 1 on the denominator is 2. Okay. 24 is not a perfect square. If you try to take the square root of 24 to keep going, you're going to get a decimal. Not just a basic decimal, but an irrational decimal. So I don't want a decimal. I need to break down 24. So I'm going to go down here in the margin below and break down 24. I'm going to say 24 is 3 times 8. 3 is prime, and I can break up 8 into 2 times 4. 2 is prime, and I can break up 4 into 2 times 2. So 24, the square root of 24 has 1, 2, 3 2's and a 3. If I'm looking for pairs, I have a pair of 2's, which can be written out front, and I can put the 2 times 3 back inside the radical. So 2 times the square root of 6 is the simplified form of the square root of 24. 2 times the square root of 6. All right, guys, here's a new step for you. All of these outside numbers, what I mean by that is the numbers outside of the square root are even. The 6, the 2, and the denominator 2. That means they can be reduced. I can reduce all 3 numbers. So I'm going to grab a different color pen here and start reducing. 6, 2, and 2 can all be reduced by 2. So 6 divided by 2 would be 3. 2 divided by 2 would be 1, and 2 divided by 2 would be 1. So when I write my final solution, I want all 3 outside numbers to be reduced. This would be 3 plus or minus 1 times the square root of 6 all over 1, but we do not have to write that denominator fraction. We also don't have to write this one either. I'm going to write it so that you see it, but it could look like just 3 plus or minus the square root of 6. These two things say the exact same thing. So I have two solutions, 3 plus the square root of 6 and 3 minus the square root of 6. They're real numbers, but they are irrational. Okay, here's my final example for you. Step 1, make sure you're in standard form. I am not. Subtract across the 9x. 6x take away 9x is negative 3x. Now I can tell the a value is negative 3, the b value is negative 3, and the c value is 8. So I'll plug things into the quadratic formula. The number out front is negative b, so that's negative of a negative, which makes it positive 3 plus or minus b squared, so negative 3 squared, minus 4 times the a value negative 3 times the c value of 8, all over 2 times the a value. Make sure you've got that plugged in correctly. Pause the video if you need to. I'm headed over to Desmos to do this arithmetic for me. Negative 3 squared minus 4 times negative 3 times 8. I am getting a discriminant value of 105. 105. So 3 plus or minus the square root of 105 all over 2 times negative 3 is negative 6. Now 105 is not perfect. I should try to simplify it. So down here in the margin, I'm going to try to break up 105. Guys, anything that ends in a 5 can be divided by 5. So you can go over to your calculator. 105 divided by 5 gets me 21. So if you're ever confused about what to start on, try some of those ending number tricks. 5 is prime and 21 is not, but I know 21 is 3 times 7. So now all my ending values are prime, but I have no pairs, so 105 cannot be simplified, which means this is my final answer. 3 plus or minus 105 all over negative 6. I'm going to box my 3 answers here. These come out quite funky. These are higher level. You have to add in that irrational breakdown on the square root. So the thing that makes these so crazy is the discriminant. It's all about the discriminant. So the discriminant on these 3, this was 57, 24, and 105. And you guys, the discriminant values are imperfect squares, or they're not perfect. They're imperfect numbers, not squares. You're going to have to break down with your factor tree, okay? All right, make sure you practice. These are high level, the highest level before we get to what's called imaginary numbers. So happy studying, and please let me know if you need any help.